You're listening to Autumn on the Air, the weekly podcast that brings you conversations about the impact of research commercialization and the people who make it happen. Join us for interviews with patent and licensing professionals, innovators, entrepreneurs, and tech transfer leaders on the issues and trends that matter most. Keep listening for an inside track on the people, IP policies, and politics changing our world.
Welcome to Autumn on the Air. Today we'll be diving into the fascinating world of blockchain, NFTs, and the metaverse and explore their potential impact on intellectual property. Joining us today is Dr. Randy Stout, a neurologist and cell biologist who serves as the director of New York Institute of Technology Com Center for Biomedical Innovation and the NYIT Imaging Center. Dr. Stout's research focuses on understanding the intricate connections between brain cells and their role in various neurological conditions. Welcome, Randy. I'm so excited to have you here on the air.
Thank you. Thanks for having me. I'm excited to talk about these really up-and-coming topics today.
Yeah, I am too. And in fact, it's funny you should mention that because everybody's buzzing about blockchain, non-fungible tokens, and the metaverse. And sometimes I know even for me, I can find it challenging to separate fact from hyperbole. Randy, can you help demystify some of these concepts?
I'm not a true expert in NFTs or blockchain, but I can know enough to understand how they work and be able to anticipate how things are going to affect areas where I am working in my research and in my role as an educator. So NFTs or NFTs are non-fungible tokens that are associated with the blockchain, which means that they are tied to a specific real world or digital object that is then registered and be able to be identified and assigned ownership within the blockchain, which is a distributed ledger that uses cryptographic approaches to be able to define ownership and identify which belongs to which in a distributed, in most cases, cryptographic approach for assigning ownership and registering items or lists of items in a ledger format. These interact with the metaverse in ways that we'll probably talk about more in a bit. But the metaverse itself is a topic that does need to be defined. There's a lot of confusion. I've seen articles asking what is the metaverse? Nobody can define a metaverse. I think it's fairly straightforward to define. People will say that there's multiple metaverses. In that they're connected, you could say that there's one metaverse that is a connected set of different kind of branches to an entity that we can define. And to go ahead and just define that the best we can, it's a place where people or other digital objects or programs, or in some cases artificial intelligence entities can interact, and it's a space for them to do that. And the thing that makes some things metaverse and other things not, and oftentimes people kind of have a hard time defining the line between those two. What is metaverse? What is just our kind of older concept of internet communications and electronic communications, is that there's a space in digital space where the relative location of entities, whether they're people interacting in this digital space or where there's programs running and digital objects representing things that people can interact with in the digital space, which is the metaverse. This space is assigned to their location, their relative location in digital space, as opposed to real world or physical world space. These entities, digital objects, could be NFTs, could be 3D models. It could be 3D models with attached programmatic elements, and those are interacting with people, and people are entering into this digital space, which we can call the metaverse, and they're doing things there. They're communicating with other people in some cases, or they could be there by themselves as far as other humans and interacting with digital objects. But the key difference between a metaverse and other forms of electronic communication in digital worlds or simulations is that the user and the other objects, entities within that digital space, their interactions are governed by their proximity in that space, in that digital or virtual space. And that determines the interactions, and that determines the user experience of that. I can give a really concrete example to delineate the difference between metaverse and not metaverse. And that's Zoom. So in Zoom, you can move your video screen, you can turn it off, and the whole a major point and utility of Zoom is that we can be anywhere and communicate with each other. We can send each other files, and even with on our screen, if we think about where we are on our screen, it can change a little bit just how you arrange it, but it's not central to where your video and the other users' videos are. It's not a central component of that experience in the utility of that tool.
No, not at all.
Whereas just moving over slightly, very similar kind of tool and application is this. There's several of these now. One of them is called Gather.town, and it is an online program. But the difference between that and Zoom is that your interactions are governed by a little two-dimensional. It's kind of like one of the old 8-bit video games like Zelda or something like that, where you're represented in digital space, and that makes it the metaverse. And you move around, and as your character moves close to another character, you start to be able to hear their audio and be able to interact with them. You can interact with digital objects that are assigned a location within that digital space. That's what makes that a metaverse and Zoom not a metaverse. There's a very bright, clear line between these two things. And so there's much more complex and complicated metaverses. And so, but building off from that, at least we can know where we are, so to say, pun intended, entering the metaverse
Exactly.
with these types of technology.
Yeah, and they're only going to get more complex with time. And, I think it would be helpful, Randy, if you could talk a little bit for our listeners who are members and employees of tech transfer offices, where they should look to leverage these emerging technologies, because it's important for them to know where they should go to find the relevant research and assets within the university. So where do you think tech transfer offices should be directing their attention when it comes to looking for potential blockchain, NFTs, and metaverse type of inventions for protection?
Great question. I am not a person who's experienced in tech transfer. I've dealt with it some throughout my career so far, from the researcher side, from the person who's creating new technology. I think with regard to the metaverse and touching on these other topics such as NFTs and blockchain, I think the place to look is first of all, when you're doing a search, you have to know what it is that you might find, or have an expectation of what you might find. You never know for sure, and that's the whole point of discovery of what you might find. But the thing to keep in your thinking as you're looking for these and trying to identify technologies coming out of this technological space is to remember that this is a new digital realm or world or metaverse, as we were talking, where people are interacting, sharing ideas, and using mostly computational tools to come up with new ideas, test the utility of their ideas, and then bring other people on board to use them or to further develop them. So that was a kind of broad answer, but and that's because there are certain areas where it's obviously going to be more, these are going to be more useful tools. So things like computer science and developing new approaches to everything from machine learning and AI to ways in which you can use these things in different types of research or engineering. But I think sometimes it might be less obvious that there's going to be, because this is a place where people are interacting without having to be tied to the same location. These are places where things like education, training and management will be done in the future more and more. And at the same time, think about how that will impact the need for real world or physical space is lessening, and look out for ways that it's using that value that the metaverse can bring to this. But of course, we can always do meetings as we're doing these past decade over the internet with video chat. So what is it about having the arrangement of you and the other users and digital objects in virtual space that brings value to meeting, training, and education? And you can apply that same kind of thinking. What is it about that's different about the metaverse compared to just regular digital chat? And when you evaluate a new technology that you notice or that's being created in your university, and you ask yourself, what value does that? How can that be changed or modified to gain better value based upon the particular use of the metaverse, or tying that to NFTs or blockchains? So it's one of those things where it really is important to know what the difference between a metaverse is versus just regular electronic communications. And just always have that in the back of your mind when you're evaluating a new technology that's brought to you. I know I didn't answer the question super precisely, but that's because the nature of this is you're always just looking for something that other people didn't see, and also helping people identify new applications for their technologies.
Yeah, so it's going to require some of our colleagues in their tech transfer offices, I think, really to get into some of these departments and talk with some of the researchers and see what they're working on, and really gaining an understanding of, how they're working in the metaverse and like you said, how it's creating that value add. And Randy, I know you're a neuroscientist and a cell biologist, and you do a lot of research. So I'm curious, I want to know about some of the applications of these technologies, the blockchains, the NFTs, and the metaverse in biomedical sciences. So I know, like I said, you do a lot of work in this area. So what are your thoughts on how they can enhance research, maybe even diagnostic testing and treatment for patients?
Yeah, so the constantly growing capability in GPUs and how that's applied to spatial computing goes hand in hand with my main focus in my research in the cell biological research has been and continues to be using different forms of very high so-called super resolution microscopy to look at things on the scale of molecules and assemblies of molecules. Because my goal is to really understand how the brain works under healthy conditions and identify those changes that lead to dysfunction in different neurological disorders. And we're doing that. It doesn't always have to be done from the very smallest scale of molecules and working up through cells and tissues. That's one of the approaches that's been particularly powerful and what I like to focus on with my research. And many years ago, almost 10 years ago now, I went to a workshop at the University of Pittsburgh's and Carnegie Mellon's Pittsburgh Supercomputing Center. And in a long roundabout way, that's how I got into starting to use virtual reality and move into this area. The short story is that I realized I needed to learn how to do 3D modeling with the program Blender. And then I connected with someone at NYIT when I first joined, Alexander Vasiliev, and he explained that virtual reality, the new commercial systems, are much faster and are very useful for forming these digital models that we were building to run simulations on. And So I just got working with him, and I saw the power of this new kind of wave of virtual reality technology. It's been around since the late 60s, early 70s, but this new consumer level virtual reality kind of was synergizing with the new computing power and the use of GPUs for spatial computing. And this was coming out of originally the video gaming industry. And so we started using that in research to visualize and gain insights into our 3D microscopy data, because it's on the scale of nanometers that we're studying these things. Not micrometers, certainly not millimeters, all the way down to nanometers. And this is in three-dimensional space. And when you have this, it's sometimes hard to gain an insight into how they interact. And so in combination with starting to use virtual reality in human behavioral research, in educational research, I also connected with a startup company in the UK that was building tools in the same software platform. I use Unity. There's Unreal Engine. They're both great. I kind of focused on Unity to build my VR applications. And the startup company was using the same thing, and we were able to work together and really go far in new methods for analyzing 3D microscopy data, the arrangement of molecules in brain cells, and how the connections are formed. And out of that has come new insights into how things are shaped and how things change when you have things like thyroid hormone deficiency, and how it's changing the structure and arrangement of other molecules in the cells that we're studying, these brain cells that we're studying. So we're using virtual reality in that way. And we haven't really moved to the use of blockchain and NFTs built on top of that in our research. But there is opportunity there, and we can talk about that more later. The other thing is just kind of forms of machine learning are used in assigning and classifying the locations of these molecules and the signal that comes from the three-dimensional information that comes from our microscopes. We use machine learning and AI algorithms to assign the location and say where the edges of things are. So finding the edges and classifying these structures. And because they're all in this 3D digital space, and we're using spatial computing principles, we can employ the power of graphics processor units and the new algorithms that are coming out for machine learning and classification of 3D data. And so all of that comes together to gain new insights into things like how the powerhouses of our cells and in our brain, mitochondria, interact with these connections between the cells. I study gap junctions. You probably hear mostly about synapses, which would be called chemical synapses. But we can talk more about kind of how we're using virtual reality and artificial intelligence to be able to gain new insights into how these cells and their structures that they're made of are changing.
So, Randy, I wanted to ask you, we were talking about the use of machine learning and virtual reality. And I also wanted to ask, how does that play into or doesn't play into augmented reality? And how does all three of those factor into the metaverse?
Yeah, so augmented reality is projecting digital objects and or creating creating information based upon in a digital space based upon real world objects, and then placing them in the real world. So you think about things like Google Glass and then HoloLens; those are considered augmented reality. Also, things like using the outward-facing camera on your iPad or some other kind of tablet, and then creating an overlay of a digital or virtual object onto a real-world scene that's in front of you, or it can be not in front of you in some cases. But there's an interesting thing that's these terms like virtual reality and augmented reality, and they have mixed reality, extended reality. These are all different terms that when you use it, it's very clear that they blend into each other. So one of the new things that you probably have seen with the next generation of headsets that have just been announced in the last month or two is this idea of pass-through. And this is a blending of the completely immersive virtual world and the Pokemon Go putting like a digital object into a real world scene just on a phone or a tablet. And there's a sliding scale between that. The new virtual reality headsets are blending virtual reality with the older concept of augmented reality by virtue of outward facing cameras. And as camera technology is already there, essentially, but as the display technology continues to improve, and we expect it will, you will get to a point where we won't be able to tell that the signal coming to our eyes through a virtual reality headset is not actually coming through our eyes, but is coming through cameras and then processed to create the representation of a three-dimensional view into the outside world, the real world. And when you have that processing through cameras and then displayed to the eyes, you can go on you can go anywhere on the scale between a fully immersive experience to you can essentially see everything in the world around you and you're just walking around, but you have this headset on. Why would you want to do that? Because you can always bring virtual objects in as much as you want and as many as you want. And these are things that are impossible. You can make a dinosaur walking in front of you down the street in front of your real world house. So these are ways that virtual reality, what are thought of as virtual reality headsets, can move into the augmented reality space via this pass-through effect that is really seems like it's going to be the future with regard to the metaverse and virtual reality. Now, I think at least for the next 10 years to 15 years, likely there's going to be a separate path that is going to be this virtual reality glasses and wearables that do have the ability to see actual light coming into your eyes from the outside world.
Oh, that's wild.
And then you're going to be able to project onto the glass or project directly into the eye virtual objects. And so this is kind of the opposite effect, the opposite side of the development of these technologies. I think at some point, as things get lighter and smaller, it's actually just going to be virtual reality type headsets are going to get smaller, but that line of technology is going to win out in the end, most likely, depending on the development of better power management and computing technologies. That's going to, and display technologies, that's going to win out in the end. But there's going to be a period in the next 10 years where there's going to be other things like Google Glass type things are going to come back and be popular. They're going to go in parallel, and then in the end, virtual reality type headsets with full capability of full immersion will end up winning out in the end. But
something like sunglasses was what I'm kind of envisioning. I'm a cyclist, and there are some glasses you can buy for cycling now that will tell you right on this inside of the glasses your speed, your cadence, what the terrain looks like ahead of you. So I can only imagine.
That's an excellent example of current augmented reality technology. You're augmenting the outside world, the information coming from the outside world through the glasses. You're adding to that using computer technology that's tracking your speed and how far you've gone, and then providing and projecting that onto the real world as a screen. And so that's augmented reality. Then you have this mixed reality coming through, and that's just kind of an extension of augmented reality, all the way to full immersive virtual reality. This pass-through effect is something that I've seen over the last couple of years, starting with the Quest 1, Meta's Quest 1. And when I first tested it out, and there's other headsets and brands have this commercial VR, but when I first tested it out, it's one of those things I realized was going to be very powerful and important. And we in my group have started using this now to be able to build things like virtual obstacle courses. We have a program where we're doing research and teaching, and we're having gamified exercise using VR with teens with autism spectrum disorder. And it's a way to both make the exercise, because exercise has all these benefits on the brain, and make the exercise more enjoyable, but also better quantify the effects of our virtual reality use of virtual reality, and just better quantify the effects of this exercise programs for neurodevelopmental disorders. And one of the things we've been doing is building these virtual reality environments where you can see the world around you, but you can run around and gather up things and do tasks on virtual objects in combination with being able to see the people around you, talk to them, but also actually incorporate real world objects into the virtual obstacle course. And so, that's one of the things I should have said earlier is when I first started using VR, you have to really think about the technology and what it's doing. And I think that that's an important principle, even for people working within tech transfer offices. And by that, I mean, I saw on one hand that it would cost tens of thousands of dollars, upwards of $100,000 for some of these, at the time, state-of-the-art motion tracking technology to track the position of people's limbs and their gaze. There's eye trackers, the things of testing head position. And if you try to assemble all those things for research or for therapy, it would cost you hundreds of thousands of dollars to create like a motion capture lab. And it's not getting as much information, and it's not as precise in some cases. But virtual reality was doing some really great, even back to 2018, really great motion capture, knowing the position in 6 degrees of freedom of your hands, your head, being able to kind of detect gaze at the time. Now there's great eye tracking in commercially available VR headsets. So what I realized, and many others did as well at the time, with these early commercial VR headsets, this new wave that started in 2013, 2016, was that they were excellent motion capture devices. Maybe it was a little bit more sparse, the data that was coming in, but we could use that in our research to be able to detect how people are moving and where their hands are doing different tasks. And it was coming in at a price point 1/10 of what you would pay for a similar technology if it was geared towards researchers and research. And as long as we have access to that data in the raw format and are able to develop our own programs for these new technologies, it's going to allow us to do things that we otherwise couldn't do. And that comes from looking at what it's doing and really, realizing, what is this thing I'm using? Well, it's something that is tracking my hands. It can apply on-demand stimuli to visual and audio stimuli, and then you can give user responses in things like not only button presses on the controllers, but you can have the user be required to take certain physical actions in the virtual space. And you can quantify all of that and feed it into downstream research-based analysis methods. And so that's the kind of expanding upon why we got into this. And as this passed through, the reason why I kind of went back to that is that's the next thing is this pass-through, and it's extremely exciting. And I hope that the developers of the actual hardware, the virtual reality hardware, and the software that goes with it, I hope they continue to do what they've done in the past for people like me and for developers who are trying to build a startup business around it. They've opened it up for developers, and I hope they do that with the pass-through stuff, with the pass-through, so you can create a blended virtual and real world. So it's an exciting area for the future, I think.
So, Randy, I wanted to ask you, your work at NYITCOM Center for Biomedical Innovation and NYIT Imaging Center involves using a lot of these innovative tools that we've been talking about, artificial intelligence, virtual reality, and imaging technologies. So can you talk a little bit about how these are impacting the development of original biomedical technologies and their impact on intellectual property?
Yeah, so these areas we formed the New York Institute of Technology Center for Biomedical Innovation out of Alex Vasiliev, who's retired from NYIT in the time since, and I took over. Along with him, we started this innovation center as a place where we can do new technologies. And so we can bring them to both the education. It's a medical school. NYIT is a large medical school in Long Island. And we wanted to be able to bring these new forms of technology to both the medical education and, just as importantly, to the research that we and other of the faculty members at NYITCOM were doing. And that meant we broke it into certain areas. One of them was simulation, visualization, and imaging. And that was paired with things like 3D printing and doing different forms of engineering and design and robotics. And some of the earlier projects were actually combining robotics with virtual reality, for example. Because virtual reality is largely focused on spatial computing and these virtual worlds where you're building and interacting with digital objects. But in those, you have less constraints of scale. And so one of the projects that Alex Vasiliev, my former collaborator, and medical students worked on, it was really cool, was you could design structures in virtual reality and then essentially digitally shrink them down to a 1,000 times or more, and then have a 3D printer with high precision that they had actually partially built the 3D printer themselves, some of the components on it, but they would then print and place things like cells, for example.
Oh, really cool.
And when you do that, you can have a repeated with the precision of the robotic arm doing this printing and extrusion of cells and materials for growth substrates for cells. You could have a repeated, very small scale structure that you define. And that's important if you're trying to set up an experiment to understand how cells grow and interact. Let's say you have cancerous cells and normal tissue and normal cells. You can put them together in an arrangement outside of the human body in repeated arrangement, and then understand how the growth of those cells differs when you apply different drugs and stuff like that. And so having something like this Center for Biomedical Innovation is kind of an important leg of the table upon which other research programs and student projects can be built. And so when you think about having the ability for a student or a faculty member to devise a new design for a robotics system, or to be able to test a new educational environment for their students, those are kind of two different parts of a spectrum of innovation or invention. Regardless of that, if you have this kind of foundation built where you have some experts in virtual reality, experts that are working together with them and are part of this innovation center who know how to build things in virtual reality, know how to do some simple machine learning development. When you have that kind of center, it forms this foundation upon which other types of innovation and invention can take place. And perhaps importantly for the tech transfer industry or groups, that creates a place where you can look, and if you have good communication and you meet with the people who are a part of the center, they can be the place where you go first, and they will know how these other inventions are working, and they can be kind of like a middle person or a a place for you to look and to be able to kind of shop around and understand what's happening. And they can be a go-between between the people, because we can't all invent for everything. We can't create new technology.
It sounds like it could help find the white space in some areas, like where there could be an invention.
Yeah, exactly. And they can be the ones to translate and also work with the tech transfer offices and personnel to identify the utility and value, which can sometimes be hard for the people who invent them themselves. They're so missing the forest for the trees kind of situation sometimes. Having this other forum to promote and build inventions is important. And I have to really give credit to the people who put this together at NYIT. It was the leadership, the administrative leadership, and the former dean asked Alex Vasiliev to do it, and Alex came to me because he had already known, and we'd had all these great conversations. So that's the background of that, and how I think it could be useful to see some form of this. And a lot of universities have things like this, like these innovation centers. It's important to have them be very open and be a place where people can work together really well. As far as the imaging center goes, that's really focused on cutting edge microscopy technology. And in that area, things like spatial computing, and especially lately over the last, I guess, 5 years or so, machine learning has become, and artificial intelligence has become a powerful tool in biological research, whether it's large scale imaging and computer vision based identification and tracking of things like animal models as they go about their behavior and quantifying their behavior, people looking at gait disorders, all the way down to like looking at how to define the clusters of molecules that at a really low level are the basis by which you have things like heart dysfunction or changes to the brain that precede neurodegeneration and loss of brain function. We're using, and we have been using for a lot longer than most people would realize, tools that come out of artificial intelligence, especially a lot of machine vision type techniques, to get better understanding of the data that we're getting in these areas of research. And so we use a lot of AI in our imaging center, the NYIT Imaging Center, to make sense of the data, essentially, that we're getting from our microscopes. And so we have some really cutting edge microscopes, basically the best you can get right now. And we're using those to make really fundamental discoveries about how cells and tissues change in different diseases, everything from heart disease to brain disorders to cancer and other types of health problems that people have.
That's pretty amazing. And I want to go back because you mentioned before about your research focusing on the interaction between brain cells, particularly the glial cells and their connections at gap junctions. So can you tell us a little bit about how, using, all this augmented virtual reality metaverse, how that's contributed to your understanding of various neurological conditions and what you think some of the potential impact will be for patients?
Yeah. So the thing that I study are gap junctions and how they connect cells in the brain. Many of the listeners think of the brain as a computer that's connected by neurons. About half of the cells by number, at least in the human brain, are a different type of cell called glial cells. And within glial cells, that's kind of an umbrella term for a bunch of different cells that have different and sometimes overlapping functions. So there's astrocytes, oligodendrocytes, and microglia are some of the main glial cell types. And those are kind of the counterpart, but not necessarily. They work together with neurons to achieve brain function. And the glia that I focus on most are astrocytes. They have a role in maintaining the function of the neurons. And they also have kind of secondary roles or dual mandates, triple mandates in some cases, where they're acting in some ways like the as part of the immune system, or damage prevention, or preventing spreading of damage in the brain, reacting to damage, whether it be an infection or traumatic brain injury, stroke. These cells have a role to play in containing the damage. But the main immune cells are called microglia, that I mentioned earlier, in the brain. But they also participate in functions like sleep, wake, and these astrocytes that I study also participate in things like sleep, wake. And it's become clear that they have a role in everything, like the processing and understanding where you are, and long-term memory formation and retention. And so they're an integral component of the way that the brain works, even cognition. And so you wouldn't have normal cognition without these cells. The gap junctions that you mentioned, that I study using microscopy and other types of scientific techniques, are the main way. They're not the only way, but they're really this extremely prominent way that these astrocytes that I was talking about, that make up, in some parts of your brain, they're the most numerous cells in your brain. These gap junctions are the connections between them. So they form what you can think of as a network, and it's extremely complicated. In this network of connections between the cells in your brain. Now, this is kind of like a different type of connection and a different network that interacts with but there's a different network that you hear about all the time: synapses, axons, neurons connecting to each other. And this is what the earliest and continuing to kind of model deep neural network-based artificial intelligence is more modeled after the neuronal connections and the way that they function. In some ways, the gap junctions that I study that connect astrocytes they're modifiable, so the strength of their connections can be modified, and it is modified based upon the activity of the cells. And so we can think of gap junctions as connections between astrocytes in our brain as a kind of separate network as to that of the neurons. And these two networks interact with each other via different signaling mechanisms. And so in setting out to understand how the brain works and how it changes in disease, I recognized that there was gaps in our knowledge around how these gap junction connections change and what they're doing. And we didn't even know exactly, we still don't know exactly everything that they're doing and how they're controlled by other parts of the cells of our brain and outside of the brain as well. There's some signaling from the rest of the body into the brain, and it's known that they affect these connections between astrocytes. So that's a long thing, because you can tell I'm really excited about learning more about these things. And the way I'm focusing on doing that is using the newest microscopy techniques, and we're developing new ways of labeling these things so that we can see where they are and how they're moving within the cells. So within that, anytime you're trying to better understand where things are, their morphology, how they're formed, their shape, and how they're moving around, you're doing that. You're taking signal from the microscope onto a camera chip or a detector, a point detector, and you are using a computer to be able to know where things are and how they're shaped. And anytime that starts to be the way that you're actually trying to extract information and gain insights to explain how things are happening and explain, problems and how these things are functioning, it's going to be useful to use the newest ways of doing that. And a simple machine learning algorithm is going to be the best way to track how a signal is moving and calculate its path, its velocity, things like that, to all the things that are going on with trying to have new self-driving cars, for example. A big component of that, of the artificial intelligence that's behind the development of better and better self-driving cars, is being able to recognize the shape of objects first, I guess, and then based upon their characteristics, what they are. And so that's a similar thing to what we're trying to do we're using our microscopes. And so we're using the things that are being developed in machine vision and classification, segmentation, classification algorithms that are being always improved using machine learning, artificial intelligence, deep neural networks. And so it's a really powerful tool in our research. With regard to VR, in that side of the research, it's something we're using to visualize and communicate information using virtual reality. And on the side of, I've kind of split my areas of research into some human behavioral research. Now they're connected through the idea that we're using exercise and the virtual reality to track how people are moving to understand motor disorders like Parkinson's disease or neurodevelopmental disorders. And then we can use our microscopes to try to create an explanation of why these certain activities or changes in motor behavior and capabilities or cognitive abilities that we're finding in VR. We can try to tie that via a mechanistic explanation for it based upon what we're doing with our microscopes. And so that's how we're using virtual reality on the side of human participant studies, and there's mechanistic connections to what we're doing on a cell and molecular level using our microscopy. Things like looking at how mitochondria change in induced pluripotent stem cells that are turned into neurons or astrocytes. And this is something we're doing from adult human patients who have, let's say, Parkinson's disease or are diagnosed with an autism spectrum disorder, and looking to see if we can detect and explain some of the symptoms and the changes that take place using our microscopes at the subcellular level. And we have biomarkers that we can use our microscopes to detect from human patients and human participants in research. So they all blend together, I guess I can say. And the use of virtual reality is on one side, and then artificial intelligence permeates the entire research endeavor.
But it sounds extremely powerful, and the ability to help visualize all that, like you were saying, and kind of connect the dots, for lack of a better word, sounds like will lead to improved treatment options for patients and probably new treatments that were probably not possible before, which is really, really exciting. Randy, I wanted to ask you, you organize VR interest group meetings, you help foster collaborations and projects that are focused on VR and computation research. Can you tell us more about some of these collaborative initiatives that you have in their goals? And are there any notable projects that are coming out of these collaborations that relate to any of the themes we've been talking about today?
Yeah. So the virtual reality interest group meeting was a place where anybody was welcome to come and present their ideas, just talk about things. And I think that's a really important thing to have, as an open place where everyone from the president of the institution to the student who just started at our university, and even people from outside, can come together and talk about the technology, their interest in that type of technology. And what that has done has was actually the way in which the several ongoing research programs at our university were based. And by talking about these technologies, you see new avenues to use them in your own research, and for students can come in and envision a project or realize that there's all these projects going on and decide to join one research program to use them. One example of that is a medical student who just graduated in May, has been just wonderful to have with me and working with me over the last 3 years. He kind of came through one of these virtual reality interest group meetings. He actually came to our medical school because he saw some news piece that came out about using virtual reality for medical education. And he worked with me for 3 years. He was an amazing person. It was just an excellent person to work with. And I hope I can and will work with him again in the future. He's all going off. He graduated from medical school. He's all going off to do his residency. But he was really capable in developing and programming and building virtual reality environments. And out of that has come an IRB approved, so an institutional review board approved educational research that ran so that people in parts of the medical education that really require you to be in front of a patient to practice recognizing signs and symptoms of the patients. When the pandemic hit and when he was first started working with me, we worked together and built with some other faculty as well. We built a virtual reality based training program, and then went about getting IRB approval. And we sent these VR headsets home with the students in waves, and we had 25 VR headsets that we were sending them. They would keep them for 2 weeks, and then we would do assessments on how well they did in virtual reality, but also how they perceived the educational experience as a way to build better and better virtual reality-based educational environments for our medical students. And then going on the other side of it, we have a study running right now with another medical student. Used a program that Edward, the medical student who just graduated, who builds all these things with me. He does 90% of the building of these virtual reality environments. We built this program for another purpose. It was for gamified exercise that we can analyze the movements in. But now another medical student is right now using that to study how, with exercise and training, the people who have a neurodegenerative disorder, how their movement changes and how their reaction time, how their precision in movement is changing using this virtual reality tool that was built completely from the ground up for use in MetaQuest 2 headsets. So that's an ongoing research study that's happening right now, and we're excited to see the results that come out from that. But yeah, those are 2 examples, and these things happen through Edward working with me, the medical student who just graduated working with me, and us being able to just chat and identify other researchers who wanted to use the things we were building in their research. So that's how the virtual reality interest group meetings and their casual, open nature is a really powerful way to move things forward.
That's incredible. And especially during COVID when, there was really a need for some of those training programs. So I think that's incredible. And it just shows the power and what the future holds for this technology. And, Randy, as the podcast comes to a close, I wanted to ask you, because you're involved in a variety of national societies, such as the American Thyroid Association and the American Society for Cell Biology. How do you see the intersection of these emerging technologies within the broader scientific and medical community?
Thank you. Yeah. So these societies that you mentioned that I'm a part of are places where people come together to discuss their ideas and present their research findings. I think everything from blockchain to NFTs to metaverse, virtual environments where it's important who you're next to in the virtual space, those will become more and more important mediums for communicating science and discussing and criticizing ideas and new concepts in science. And of course, out from that, when you're discussing these things and communicating them, those will be the basis for people to develop new inventions and ideas. The virtual reality environment is anything from a simple video screen that you're watching all the way up to these immersive virtual reality environments with face and eye tracking and full body tracking and all these things. Those are going to be those are going to be new and better mediums to communicate ideas and criticize opposing scientific concepts. These societies will hopefully adapt to that and incorporate them. I mentioned that Gather.town, which is basically the simplest form of metaverse that I can envision. That actually came from a graduate student and postdoctoral scholar organized. I came to know about that platform through a graduate student and postdoc organized meeting or conference about astrocytes and other glial cells that I talked about. During the beginning of the pandemic, they got together and they found a better way of communicating, and it is a better way of communicating. That environment allows you to have scientific posters, for example, which are an important way of showing results. So hopefully, and we see this happening. These societies that are a vehicle for scientific discourse are going to continue, and the societies that do well and grow in the future will be those that employ these technologies. And these are going to continue to be, the societies are going to continue to be important to bring people together around the scientific topic of choice. And then those societies that do well and grow will be the ones that use these forms of technology that we talked about in a way that adds value for their membership. The blockchain. Well, there was a debate about this, and there's some differing viewpoints. But blockchain as a distributed cryptographic ledger is likely to be a useful tool in scientific communication going forward. Now, people go off astray a lot on these things and assume that they're going to get rich quick or
exactly.
Find out in the scientific viewpoint, make their lab rich with funding quick, and it's kind of a lot of times people go for the shortcut, but there is a utility in these technologies that will find a place within the scientific research community and also the communication of scientific results. I would look forward to metaverse based conferences that would allow people who can't travel or it's too expensive for them to travel to communicate in a way that's more like these conferences. These international scientific conferences are so valuable because it's a place where ideas are discussed, debated, and communicated in a way that has had great utility for me and my research, and it's clear that they're useful. So if we can kind of combine that and gain the benefits of that we can see through blockchain, but even more so virtual reality and metaverse, newer technologies that are coming out in those areas, I think we can amplify the already extremely strong utility of these conferences and the international societies and scientific societies that establish and organize these conferences. So, yeah, I'm excited about the future, and I'm going to try to bring these technologies to these societies of which I am a part.
Well, Randy, thank you so much for all your time today. This has been an absolute pleasure, and your expertise in this area is incredible. And I can't wait to see the impact that this technology has on your continued research. And thank you so much for all your time today and for being on the podcast.
Thank you very much. This has been really fun, and I'm really appreciative to be able to even talk about this. So thank you.
Thanks for listening to Autumn on the Air with Lisa Mueller. Get social with us and share your thoughts. You can tweet us at AUTM or visit us online at AUTM.net. We'll be back next week on the air. Be sure to join us.
New to tech transfer or a seasoned pro? AUTUM is the global member organization for tech transfer and is here to help you get connected, get smart, and get ahead. Whether you work in academia, research, government, business development, corporate engagement, or startups, AUTUM is dedicated to supporting you through education, advocacy, networking, and promotion. Join and you'll receive 20 free live webinars, as well as meaningful discounts on meetings and courses, insider access to a vast network of colleagues to help you through challenges, and align on new technologies and the university decision makers who license them. Membership is open for 2023. Join us.